Hello and welcome to this walkthrough video. This one's my AQA Foundation Paper 2 practice paper. This paper has been written using my key topics revision list, which you can find now on my website. If you want to give this paper a go beforehand, you can find a link to it in the video's description. So for this first question, we have p add p add p add p. When you add together terms like this, you just need to count up how many you have, so we have 4 p's there, and the answer is 4p. For the second part of this question, we've got c multiplied by c multiplied by c. The when you multiply is a bit different to when you add. You want to count up how many c's you have, which is 3, but this time it will be c to the power 3, rather than 3c. For question 2, we need to convert 2 meters into centimeters. Now you should know that 1 meter is the same as 100 centimeters. So if we want 2 meters, we just need to multiply 100 by 2, so 2 lots of 100 is 200 centimeters. For the next part of this question, we need to convert 400 grams into kilograms. You need to know that 1 kilogram is the same as 1000 grams. But this time we're going from grams over to kilograms, so we need to divide this time. So we're going to do 400 divided by 1000. Remember, you've got your calculator if you need it for that. You'll end up with the answer 0.4. For this question, we need to write the number that's represented by the arrow on this number line. If you get a question like this, I'd recommend trying to work out what each of those spaces represents. So for example, let's imagine each one of those gaps is 0.1. Then we'd have 4, 4.1, 4.2, 4.3, 4.4, but next would come 4.5, but we end up at 5, so it can't be 0.1. What if it was 0.2 for each gap? Then it'd go 4, 4.2, 4.4, 4.6, 4.8, 5. So that one does work, so the answer to this question where the arrow is 4.2. For the first part of this question, we need to find the mode of these numbers. The mode is the number that's most frequent. So looking at that list, I can see there's a 6, there's an 8, there's 2 4s, but there's 3 10s. So 10 is the most frequent number, so the mode is 10. For the next part, we need to find the median. Now the median is the middle number when we write the numbers in order. Unfortunately in the question, they're not in order, so we need to write them in order first. So we've got 2 4s, we've got 1 6, 1 8, and then those 3 10s. Now we can find the middle number just by crossing off pairs of numbers. So we'll cross off the smallest and the largest, and then do that again, and then you can see the middle number is 8. So the answer for the median is 8. In this question, we need to list all of the possible combinations that Natalie could attend. So we need to pick one of the topics from the number box, one from the algebra box, and one from the geometry box as well. For example, the one they've given us is fractions, and then from the next box, equations, and from the final box, trigonometry. So that's the one FET, and you can see they've already done that for us. So to work out the next one, let's keep fractions, let's keep equations, but instead of trigonometry at the end, let's switch to circles. So that one would be FEC. Now since we've done fractions, equations, trigonometry, and fractions, equations, circles, that must be all of the ones with fractions and then equations. So let's change from equations in the middle box. Let's go for fractions, substitution, and trigonometry. And then we could also change the end box as well, so fractions, substitution, and circles. Now we've done all of the possibilities that start with fractions. You can try, but you won't find any more. So let's start with negative numbers. So let's go negative numbers, equations, trigonometry, negative numbers, equations, circles, negative numbers, substitution, trigonometry, and finally negative numbers, substitution, and circles. So these are all 8 of the possibilities. For the second part of the question, it says what fraction of the possible combinations have equations and circles. So we're looking at our combinations from before for ones that have an E and a C in them. And you can see it's just these 2 here. So there are 2 of those which have equations and circles, and there are 8 possibilities altogether, so it's just 2 over 8. Which you may simplify if you wanted to 1 over 4, but it didn't say to in the question. For this question, we're told we have b and c, which are 2 different integers, and we're also told that b is greater than c. We need to find an expression for the sum of b and c. When we say sum in maths, we refer to adding, so we just need to add b and c together, so the expression is b plus c. For the second part of this question, we need an expression as well, but this time it's for the range of b and c. To find the range, you do the biggest number, take away the smallest number. Now if you remember in the second line of the question, we were told that b is greater than c. So if b is greater than c, b must be the biggest number, and c must be the smallest number. So we just need to do the biggest, which is b, take away the smallest, which is c. So it's b, take away c. In this question we need to solve an equation. I can see we've got a plus 3 term on the left hand side, so I'm going to subtract 3 from both sides. If I subtract 3 from the left hand side, that will cancel the plus 3, just leaving me with 5x. And then on the right hand side we've got 32 take away 3, which is 29. Now since we've got 5x on the left hand side, that means 5 times x, so I need to divide by 5 on both sides. 5x divided by 5 is just 1x, and then on the right hand side 29 divided by 5, remember you have your calculator, so type that in, and you'll end up with 5.8. So the answer to this question is 5.8. For this question we have a number machine and we need to work out the input. So we've already been given the output, we can see that's 80 on the right hand side. So we need to work our way backwards through this number machine to work out the input. Whenever we go backwards through a number machine we must do the inverse operation. So rather than subtracting 4 going back here, we're going to add 4, and then rather than multiplying by 8, we're going to divide by 8. So we start with 80 and we add 4, which is 80 plus 4, 84, and then we divide this by 8, so 84 divided by 8, and again use your calculator for this, and it will tell you it's 10.5. So the input must be 10.5. For the second part of this question we have Shana who's going to input a positive whole number, and we need to choose the correct statement. So let's choose a positive whole number. I'm going to start with 1. What happens when we input 1? Well, if we input 1, we first need to multiply it by 2, which gives you 2, and then we need to add 3 to that, which gives you 5. So when we input 1, the output is 5. Now 5 is an odd number, so we can't tick the first box. The first box says the number will always be even, and we've just shown you're able to get 5, which is not even, so it's not the first box. But it could be the bottom one, the output could be odd or even, or it could be the second one, the output is always odd. So let's try another number. Let's go for 2 this time. So if we input 2, times it by 2, you end up with 4, and then add 3 to that, you end up with 7, which once again is odd. So it looks like it could be the middle box, but let's have a think about this. When you input a number and you times it by 2, it won't matter what number you end up with, you're going to get an even number, since when you multiply any number by 2 it becomes even. Then we're going to add 3 to that, and if you add 3 to an even number, you'll always end up with an odd number. So it doesn't matter what you choose for your input here, your answer will always be odd. So the answer to this question is the output will always be odd. For the first part of this question, we need to find the number that Sharon has placed incorrectly. So looking at this table, we've got prime numbers here. Prime numbers are numbers that have exactly 2 factors. So for example, 2 is only factors of 1 and 2, 3 is only factors of 1 and 3. So some prime numbers you need to know are 2, 3, 5, 7, 11, and so on. So if we look down this prime number column here, you can see we've got 2, we've got 3, we've got 5, we've got 7, but then we've also got 9 here. 9 is snuck in, 9 is an odd number, but it's not a prime number, so it must be in the wrong place. So the answer to this question is 9. For the second part of this question, Sharon's going to select a number and we need to know the probability it's an even prime number. So looking at the table, we can see there's only one even prime number, that's the number 2, and there are 10 numbers altogether. So the probability would be 1 out of 10. For this question, we need to take the numbers from 1 to 10, and we need to place them in the table. So we're going to work through each number and decide if it's a factor of 10 or a factor of 15 or not. So let's start with the number 1, where 1 is a factor of 10 and 15 since 1 goes into any number. So we'll put 1 in the box that's a factor of 10 and a factor of 15. Then we move on to 2. Well, 2 goes into 10, but it doesn't go into 15. So that needs to go in the box that's a factor of 10, but not a factor of 15. Then we move on to 3. Well, 3 doesn't go into 10, but it does go into 15. And then 4. Well, 4 doesn't go into 10 or 15. Then 5. Now 5 is a factor of 10, and it's a factor of 15. It goes into both of them. Then on to 6, which doesn't go into either of them. And nor does 7, nor does 8, and nor does 9. And finally, the number 10, that's a factor of 10, but not a factor of 15. So that goes here. For this question, we're looking to find a missing angle. The first thing to spot is this angle here. We'll go with that 273 to make angles around a point. And you know that angles around a point must make 360 degrees. So we can find this red angle that I've marked by doing 360 take away 273, which gives you 87. So this angle here is 87 degrees. Now if we focus on the triangle, you need to know that angles in a triangle add up to 180 degrees. So all 3 of those angles must make 180. Now we know two of them, we've got 87 and 31. So let's add those together, which gives you 118. And then if we subtract that away from 180, we'll find x. So 180 take away 118 gives you 62, which is the answer to the question. For the first part of this question, we need to work out the range of the prices. We saw the range earlier, it was the biggest take away the smallest. So let's do the biggest price, which is £2.35, subtract the smallest price, which is 90 pence. So I just use my calculator for this, £2.35 take away 90 pence, which gets you £1.45, and that's the answer to the question. For the second part, we need to write down a ratio. It's the ratio of the price at shop B to the price at shop D. So at shop B it's £1.95, and at shop D it's 90 pence. So I'm going to write this ratio down, but I'm going to convert the £1.95 into pence. So it's 195 pence to 90 pence. Now it also does say to give this in simplest form, so we need to simplify this. Now I can spot they're both in the 5 times table, so I'm going to divide them by 5. I'd use my calculator for this. 195 divided by 5 is 39, and 90 divided by 5 is 18. Now you might think that's finished, but there is another thing we can divide by here. We can divide those both by 3. So 39 divided by 3 is 13, and 18 divided by 3 is 6. So the answer to this question is 13 to 6. In this question, we've been given some information about a circle. We know it has a centre at point C. We've also been told the radius is a whole number measured in centimetres, and the area of the circle is between 20 and 60 centimetres squared. So we need to try and draw a circle that fits this information. So, let's imagine this radius, which is a whole number, was 2 centimetres. Would the area be between 20 and 60? Well, to find the area of a circle, you do pi times the radius squared. So if we go with 2 centimetres, like I suggested, we do pi times 2 squared, and type this into your calculator, and you'll end up with 12.566 and so on. Now unfortunately that's too small because it needs to be between 20 and 60. So let's try the next whole number. What if the radius is 3? We'd do pi times 3 squared, which gives you this number. Now that one is between 20 and 60, so that's okay, and we could draw that circle. Or pi times 4 squared, which gives you 50.265 and so on. That's also between 20 and 60, so that one would be okay. But pi times 5 squared gives you this number, which is too big, since it's bigger than 60. So, the circle that Paolo must have drawn must be either a radius of 3 or a radius of 4, and it won't actually matter which one you draw in this question. So if you go over to the grid, you'd want to use a pair of compasses for this. So you could set your pair of compasses to 3 centimetres by placing the sharp bit at C and the pencil somewhere like this. You can see that's 3 squares away. Then from here you just draw yourself a nice neat circle. Now of course we said it could also be the 4 centimetre circle, so you could put your pencil here and draw a circle like this. I wouldn't draw both circles here, but either of those would be correct. Now for the second part of this question, we need to give the area of the circle we've just drawn. Now if you drew the 3 centimetre circle, we've already done this, it's pi times 3 squared, which gets you 28.274 and so on. The question says to give your answer to 1 decimal place though, so if we round that to 1 decimal place, the 7 tells us we need to round the 2 up, so it's 28.3. Now if you instead did the one for 4 centimetres, you do pi times 4 squared, which gives you this number, and that rounds to 1 decimal place as 50.3, since the 6 will tell the 2 to go up to a 3. In this question we have 3 shapes, and we've been told the area of shape A plus the area of shape B equals the area of shape C. Now for shape A, I can see we've got an x there, and that's also what we're trying to find, so we're going to work out the area of shape B and C first. So shape B is a triangle. To find the area of a triangle, you do 1/2 times the base times the perpendicular height. So we'll do 1/2 times the base, which is 5, times the perpendicular height, which is 6. 1/2 times 5 times 6, again, use your calculator for this, is 15. Now shape C is a trapezium. You can tell that because we've got the parallel lines marked on with those arrows. For a trapezium, you need to use the formula 1/2 A plus B H, where A and B are the parallel lines and H is the height. So we need to do 1/2 times the sum of the parallel lines, so the parallel ones are 7 and 10, and then multiply this by the height, which is 4. I would type all of this straight into your calculator as it is there, and you'll get 34 centimetres squared. So we know the area of shape B and the area of shape C. But remember we were told A plus B gives you C. So whatever the area of shape A is, we must add it to B to get C. So if we do 34 take away 15, we'll find the area of shape A, which is 19 centimeters squared. So if we know the area of shape A, which is a rectangle, is 19 centimeters squared, we can just multiply 2.5 by x, since that's how you find the area of a rectangle, which gives you 2.5x, and this needs to give you 19. So to find x on this one, you just divide both sides by 2.5. Use your calculator for this, 19 divided by 2.5 gives you the answer as x equals 7.6. For this question, we're given some information about how the prices of tickets are going to change. An adult ticket is going to increase by 8% and a child ticket is going to decrease by 15%. We are also given the prices of those tickets before those changes happen. So, let's start with the adult ticket price. That's going to increase by 8%. So let's find 8% and then add that on. To find 8% of a number, you just multiply it by 0.08. So let's do 0.08 times 375, and that'll give us this, £30, which represents 8%. But it's an 8% increase in price, so we need to add that on to the price of an adult ticket, which is 375. So 375 plus 30 gives you £405. So that's the price of an adult ticket after we've increased it by 8%. Now let's move on to the child ticket. So the child ticket is going to decrease by 15%. So let's find 15% first. To do this, we use the multiplier 0.15. So 0.15 multiplied by 190 gives you this, £28.50. So that's 15%. But it's a decrease, so we need to take that away from the normal price of a child ticket. So £190 take away £28.50 gives you the new price of a child ticket of £161.50. Now we're ready for the final part of the question. We have Andrew who's buying these tickets. He wants one adult ticket and two child tickets. So one adult ticket, that's just £405, plus two lots of the child tickets at £161.50. If you use your calculator to do this, you'll end up with this answer here, £728. In this question, we're told about the ratio for time playing football to time playing hockey, and that's the ratio 5 to 7. So let's write that down. For football to hockey, the ratio is 5 to 7. Now, since we're dealing with the total time in this question, let's create an extra column here for the total number of parts of the ratio. If you add together 5 and 7, you get 12. So there are 12 parts to this ratio. Now, we're told in the question that Miriam's going to spend 3 hours playing football. But if you notice, the answer to the question needs to be in minutes. So let's convert those hours into minutes. Each hour is 60 minutes, so we just need to do 3 times 60, which is 180. So she plays sport in total for 180 minutes. So let's place the 180 underneath the total column, since it's the total amount of time she plays sport. Now we need to consider how we can get from 12 to 180. That's multiplied by 15. If you're unsure how to do this, just use your calculator and do 180 divided by 12. That'll give you 15. So to get from 12 to 180, we multiply by 15, so we need to multiply the other parts of the ratio by 15 as well. 5 times 15 is 75, and 7 times 15 is 105. So this tells us she spends 75 minutes playing football and 105 minutes playing hockey. Now the question wants to know how many minutes she spends playing hockey, so we want the 105 as the answer. For this question, we need to find the highest common factor of 56 and 70. To do this, I'm going to write each of those numbers in its prime factor form. Now you can do this very easily on most calculators. If you press 56 and then press equals, your calculator will just show you 56. That's important because it places 56 into the calculator's memory. Next, we're going to look for the button that says fact, F-A-C-T. On most calculators, you're going to need to press shift first and then the fact button. So shift and then fact. This will probably tell you that 56 equals 2 to the power 3 times 7. Then we'll do the same for 70. So clear your calculator and then press 70 and then equals. Remember, this puts the number 70 into your calculator's memory. Then press shift, then fact again, and it will tell you that 70 equals 2 times 5 times 7. Now before we do the next bit, I'm going to rewrite that 2 to the power 3 as 2 times 2 times 2 again, so 3 times. So 2 times 2 times 2 times 7. Then I'm going to draw a Venn diagram. So we have 2 circles, the first one for the 56 and the second one for the 70. Next we're going to look at the prime factorizations and look for numbers that appear in both of them. I can see first of all there's a 2 in both of them, so I'll cross those out and put a 2 in the middle. Looking across, I've got some more 2's in the 56 one, but there aren't any 2's in the 70 one. I've got a 5 in the 70, but not in the 56, but we do have 7's in both of them. So if we cross off those 7's, and we'll place one 7 in the middle. Now there's nothing else that matches up, so we need to place our remaining numbers in the circle still. So these two 2's here will go into the 56, and the 5 here will go into the 70 circle. So now we've completed this Venn diagram, the highest common factor is always found by multiplying the numbers you have in the middle of the Venn diagram here. So we just need to do 2 times 7, which gives you 14. Now sometimes the question may ask you for the lowest common multiple instead. If it's the lowest common multiple, you would multiply all of the numbers you can see in the Venn diagram here. So we'd have the two 2's from the 56 circle, the 2 and the 7 from the overlap part, and the 5 in the 70 circle. So if it said find the lowest common multiple, you'd use your calculator to do 2 times 2 times 2 times 7 times 5. In this question, we're looking for the cheapest way to buy 20 lollies, and you can see we've been given 3 options here. So in the first one, a single lolly costs 16p. The second one, we got a pack of 4, and the next one, we got a pack of 12. So we need to go for the deal that gives us the best value. So for the first one, we can tell it's 16 pence for each lolly. Let's work out how much it costs for each lolly in the second and third deal. For the second deal, if it's 85 pence for 4 lollies, we can just do 85 divided by 4, which gives you 21.25 pence per lolly. So in the second deal, each of the lollies is costing us 21.25 pence. So it's not a very good deal because we can buy a single lolly for 16p. Let's do the same thing for the final one. So we've got £1.74, which is 174 pence, but we get 12 lollies. So we'll do 174 divided by 12, which gives you 14.5 pence per lolly. So actually that's really good, it's better than both of the other deals. So given the choice here, we want to go for the pack of 12 lollies because that's the cheapest per lolly, and then the single lollies, and we want to avoid the most expensive deal, which is the pack of 4 lollies. So remember, we're trying to buy 20. So we're going to go for the pack of 12 lollies, but we can only buy that once. If you bought it twice, you'd end up with 24 lollies, which is too many. So let's buy one pack of the 12 lollies first for £1.74, and then we'll go on to the single lolly deal since that's better than the pack of 4 lollies, and we'll do that 8 times so that we end up with 20 lollies in total. This would cost us £1.74 plus 8 lots of 16 pence, and if you type that into your calculator, you'll end up with £3.02. For the first part of this question, we need to describe fully the single transformation that maps triangle A onto triangle B. Well, if you look at triangle A, to get it to triangle B, you need to turn it around. So this one's a rotation. The question is, where's it been rotated around, and by how much? So what I would do for this question is take a piece of tracing paper, trace around the shape A, place your pen onto the tracing paper and turn it around and hope that shape A lands onto shape B. Now you may not get it right first time, and that's okay, it may take a few goes, but eventually you will be able to find that the cross that you need to place your pen on would go here. So if you place your pen on this cross and turn this around, you'll find eventually it lands perfectly onto shape B. So we need to describe what we just did there. Well, first of all, we did a rotation. It went around half a turn, so that's 180 degrees. Now I've said 180 degrees clockwise here. You don't actually need to say the clockwise if it's 180, because 180 degrees anti-clockwise is still the same. But if it were a 90 degrees or a 270 degrees, you would need to give the direction as well. And then finally, we need to say the point we rotated it about. Well, that's where the cross is. That's at the point 6, 3.5. For the second part of this question, we've been asked to translate triangle A using this vector here, 0, 2. Now when you have a vector, the top number tells you how far to move left or right, and it's actually 0, so we're not going to move left or right at all. The second number tells you how far to move up or down, and if it's positive you go up, and if it's negative you go down. So since it's positive, this vector is just telling us to move the shape 2 squares up. So let's take the shape A, and if we move it 1 square up, and then 2 squares up, it ends up here, and they've asked us to label that triangle C. For this question, we need to write down an error interval. To do error intervals, I like to draw out a sketch of a number line. I'll always place the number from the question in the centre. So we've been told 330 millilitres, so let's put that in the middle. This has been rounded to the nearest 10 millilitres. So I'm also going to write 10 millilitres below that and 10 millilitres above that. So 10 millilitres below is 320 and above is 340. Then the error interval will be represented by this highlighted region here. This is halfway in between those pairs of numbers. So what's halfway in between 320 and 330? Well, that's 325. And what's halfway in between 330 and 340? That's 335. So these are the ends of your error interval, so the lower bound here will be 325, and the upper bound 335. For the second part of this question, we've been told about a larger cup, which has 3 times the capacity. Now if it's got 3 times the capacity, we just need to multiply our previous answers by 3. So 325 times 3 is 975, and 335 times 3 is 1005. For this question, we've been asked to work out an estimate for the mean length of the song. To do this, we're first of all going to write down the midpoint of each of the groups. So we've got this first group from 0 to 100, the middle of that is 50. Then this next group from 100 to 200, the middle of that is 150, and for the final group from 200 to 300, that's 250. Then we need to multiply all of the frequencies by these midpoints, so 1 times 50, 8 times 150, and 7 times 250. 150 is just 50, 8 150s is 1200, and 7 times 250 is 1750. The next thing to do is add up this final column. That will give us the total length of all of these songs. So if we add up this column here, we end up with 3000. Next we need to divide this by how many songs there were. You can find this by adding up the frequency column here, but we were also told in the question there are 16 songs, so we can just divide 3000 by 16. And that gives you the answer 187.5 seconds. In this question we have some statements and we need to tick the correct box. So for the first one it says the coordinates of the y-intercept are 0, 3. The y-intercept of any graph is where it crosses over the y-axis, so for our graph it's here. And you can see the coordinates of that are 0, 3, so this must be true. Now let's move on to the second statement. It says the gradient of the line is -1. The gradient of a line is how steep it is. Now any line that's going upwards like this one has a positive gradient. If it had a negative gradient it would slope downwards instead. So the gradient of this line cannot be -1 since it must be a positive gradient. So this one cannot be true. Now on to the final statement. The gradient of the graph equals 2. For this part of the question we need to notice that Veronica forgets to label the x-axis. So this means there are no coordinates at the bottom and you can see it's empty. So what we need to do is put in some numbers and see what gradients we can come up with. So if we imagine that 1 squared just represented 1, we'd end up with some coordinates like this. Now to find the gradient you need to do the change in y divided by the change in x, and I like to do this by drawing a gradient triangle. So I just pick 2 points and draw a nice triangle between them like this, and then write down the change in y and the change in x. The change in x for this triangle just goes from 1 to 2, so that's 1, and the change in y goes from 4 to 5, so that's also 1. Then we do 1 divided by 1, which gets you 1. So if we did this scale for the x-axis, we'd end up with a gradient of 1, not 2. But if we changed it instead so that each 2 squares represented 1, something like this, now if we draw a gradient triangle, this one here, the change in x is still 1 because it goes from 1 to 2. But the change in y goes from 5 to 7, so that's 2. So to find the gradient here, we do the change in y, which is 2, divide by the change in x, which is 1, and 2 divided by 1 is 2. So because we haven't been given the scale for the x-axis, we've shown the gradient could be 2, but it also may not be 2. So we need to tick the middle box, could be true. In this question we have Gareth who has £5,000 and he's going to invest it in a bank with 3.5% compound interest. We also know that Gareth wants to withdraw the money once he has over £1,000 in interest. If he's going to invest £5,000 and he wants at least £1,000 in interest, we need to do 5,000 plus 1,000, which is 6,000. So we're looking for when the amount of money in the account hits £6,000. So let's try and work out how much money he would have at the end of each year and look for the first one that's above 6,000. So he's going to invest £5,000 and the interest rate is 3.5%. To increase a number by 3.5%, you multiply it by 1.035. So if we do this for 1 year, we do 5,000 times 1.035, which is £5,175. So we're looking for £6,000, so at the moment we're a very long way off. So let's now find out how much he would have after 2 years. So we start with 5,000, but this time we times it by 1.035 squared, The squared is to represent the fact that we're doing it for 2 years. If you type this into your calculator, you get this number here. So we're still not at £6,000. So now we'll look at 3 years. This time you'll multiply it by 1.035 to the power 3, since it's 3 years. That gives you this number here, so we're still not there. And then we can do 4 years, so to the power 4, which gives you this, still not there. 5 years, which gives you this. Now that's very close, but still not enough. And then 6 years. Finally, after 6 years, we do get above £6,000. So the answer to this question is 6 years. For the first part of this question, we have a sequence, and we're told it's an arithmetic sequence. This means that to get from one term to the next, you must just add or take away the same number each time. So for this sequence, you can see to get from 1 to 4 is just add 3. That means to get from 4 to the next term, we just add 3 again. So 4 add 3 gives you 7. And to get from 7 to the next term, you add 3 again, and 7 add 3 is 10. So the third term of this sequence is 7, and the fourth term is 10. Now for the second part, we have the same sequence, but rather than being arithmetic, it's geometric. For a geometric sequence, to get from one term to the next one, you're going to multiply or divide this time, not add or subtract. So how do we get from 1 to 4? Well, that's 1 times 4. So to get the next term, we need to multiply by 4 again. 4 times 4 is 16. And to get from the third term to the fourth term, we times by 4 again. 16 times 4 is 64. So the third term of this sequence is 16, and the fourth term is 64. For this question, we've been asked to use trigonometry to work out the value of x. To do this, we're going to start by labelling the triangle. The hypotenuse of the triangle is the one that's opposite the right angle, so that would be this one here, the 20. The opposite is the one that's opposite the angle in the question, so opposite that x is O down here. And A is the final one, the one that's next to the angle, that's here, the adjacent. Now we need to work out which one of those we don't need. We don't need the opposite in this question since we're given H and we're given A. So we've just got A and H left, let's write out SOHCAHTOA and look for the one of those that has both an A and an H in it. And if you look at CA for cos, you can see that does have an A and an H. So we're going to need to use cos. So we can write out cos of the angle, which happens to be x, equals the adjacent. Now the adjacent this time is 5, and then we divide it by the hypotenuse, which is 20. So we can write cos x equals 5 over 20. Now since we're finding an angle in this question, we need to use the inverse cos function. So we would do inverse cos of 5 over 20. Now if you're trying to find the inverse cos button on your calculator, you'll probably need to press shift and then cos. If you type this into your calculator, you'll get the answer 75.5, remembering to round it to 1 decimal place. For this question, we need to rearrange this formula to make C the subject. So let's start with the formula. To make C the subject means we need to have C on its own on one of the sides. So at the moment, the C is on the right-hand side, but we also have a 10 there and an A, so we need to eliminate both of those. We're going to start with the 10, so if we subtract 10 from both sides, on the left-hand side we've already got a P, but we subtract 10, so that's P, take away 10. But on the right-hand side, the 10s will now cancel, so we're just left with AC. Now we've just got an A with the C. That A is multiplied by the C. AC is just A times C. So we need to divide both sides by A. If you divide the left-hand side by A, you've got P minus 10 already there, but then you divide that by A, and on the right-hand side the A's will cancel to leave you with C. So now C is the subject because it's on its own. Usually we write the subject first, so I would rewrite this as C equals P minus 10 over A. And for this final question, we need to solve a quadratic equation. To solve this, we're going to need to factorise it. To factorise it, we're going to look at this last term here. We're going to think of the factor pairs that multiply together to give 22. Now there's only actually 2 of these, 1 and 22, or 2 and 11. Then we need to select the pair that adds together to make 13. So it's not 1 and 22, that makes 23, but 2 plus 11 does make 13. So that's the pair we need. This tells us that when we factorise it, the brackets will be x plus 2 and x plus 11, and this equals 0. Now we move on to the solving part since we factorised. We look at this first bracket here and say, what if that was equal to 0? We'd have x plus 2 equals 0. And to solve this, we just subtract 2 from both sides. If you subtract 2 from the left, you get x, and if you subtract 2 from 0, you get negative 2. And then we look at the second bracket. What if x plus 11 was equal to 0? Well, we would just take away 11 from both sides. This would give you x equals negative 11. So they're your two answers, x equals negative 2 and x equals negative 11. Thank you for watching this video, I hope you found it useful. I've put some suggested grade boundaries here, but remember we don't really know the real grade boundaries until after the papers are done. Check out the video I think you should watch next and subscribe so you don't miss out on future videos.